Are you failing math?
Nah, of course not.
Do you need help?
No, I don't think so.
I think you do.
No, not really. Okay. Whoa. I'll take some help.
Good. If you were like my previous guest, then you need help. Bringing to you the all-new, 100% guaranteed, the Sigma. The Sigma. This product is guaranteed to get you an A in math using 100% guaranteed methods. You might be wondering, Mr. Drew, how can I get 100% on my benchmark? Well, boys and girls, using the Sigma, this is possible, and I'm about to show you how. Now kids, before we show you a math problem using Sigma, you have to know what Sigma is. Now, Sigma, or summation sign, is used to express series, which are based off of sequences. Now, as you see here, this is an example of the Sigma sign. These are all the terms around the Sigma sign that we write, so you know how the series is expressed. Now, this is the first term in the series. Now that this term, let's say that this term is 1, okay? Now you use this term to find what the actual series is. This is what you square or multiply or add to find the next term in the series. So let's say if this is 1, then we would keep going and going, like 1 squared equals 1, then 2. 2 squared equals 4. So 1 plus 4, and then we keep on going. But then how do we know when we're done with the series? The top term is the digit that tells us which number to end at. And that is the digit that we plug in to here, and we get our final digit for the series. Now let me show you an example. Let's say this is the problem that you have been assigned. Now you have to express this in a series. This is the Sigma notation. This says that n equals 1. And it shows that this part is 2n. So now, what would I have taught you? Since n equals 1, that means 1 is the first digit. What you do is you plug this in here. 2 times 1 is 2. So 2 is the first digit to the series. Then, n equals 2. You keep on going. You add one more digit every time. So, once we have 2, the next digit would be 2. 2 times 2. 4. So, 2, then 4. Then the next digit would be 3. So we would keep going on and on like this. So we look at the top term and we realize that it's 50. So, here is our series then. We would keep on going until 50. 50 times 2 is 100. And we know that that 100 is our last term in our series. Let me see what my student has been working on.
Bobby, look what I've done.
Oh no, Billy. That is very wrong.
Oh no, what will I do? Oh.
Alright, Billy.
Do this. I'm gonna fail. Oh.
No, don't worry, Billy. I have my new product with me. It's 100% guaranteed to give you what you want. An A in your class. I give you the Sigma.
Whoa. I know how to do it. I have the power of the Sigma.
Okay, Billy. Now that you have the power of the Sigma, show us how it's done.
Okay, Drew. So, first, we're gonna make the Sigma. Make this little E-shaped thing. The Sigma. Alright, so first, let's pretend that the first value that we're gonna plug in is 1. So let's make n equal to 1. Because it's always good if you start out with 1. It's easy to remember. So then what we have to remember is that we have to do something to 1 in order to get 2. So we can do two things. We can either multiply by 2 or we can add 1, because 1 plus 1 is 2 and 2 times 1 is also 2. But only one of them can work. So to see which of those we're going to use, we're going to select this second one. So if n equals 1 and then we do something to 1, we get 2. Now n equals 2. We're going to do something to 2 and we're going to get 4. So if the rule is to add 1, let's say theoretically, it's to add 1. So 1 plus 1 is 2. Then the second term should actually be 3 instead of 4 because 2 plus 1 is now 3. So because of that, it can't be n plus 1. So it has to be 2n because 1 times 2, or 2 times 1 is 2. 2 times 2 is 4. 2 times 2 is 4. Then when we make n equal to 3, 3 times 2 is 6. And we keep going on until we get to the last number, which is 1,000, which is given right here. So what's going to be our top number right here? Well, we know that n has to be some number, and then we multiply that number by 2, and we get 1,000. So basically, we can either do it in our head, and just think about it, or we can do it algebraically. And the way you do it algebraically is basically have this, so 2n, and set it equal to 1,000. Because you want to find what value of n is going to give me 1,000 when I plug it into this thing right here. So now we just divide both sides by 2, n is equal to 500. So we put that up here. So basically that means the number where we're going to stop is going to be 500. Because 500 times 2 is 1,000.
Okay, kids, I'm glad you learned something today. I gotta run, but I'll catch you later. Oh wait, I'm forgetting something. Geometric sequences. Now, geometric sequences. You use the sigma to find a different kind of sequence. Now, here's how we solve geometric sequences to express them with a sigma. Now, you're given a sequence or a formula for these. Let's say something like t to the n is equal to 3 times 5 to the n minus 1. Just an example. For n from 1 to 5. Now, as we looked at earlier, this is the sigma, okay? Now, the first digit is n equals 1, as stated in the problem. And the last digit, since it's stated from 1 to 5, n equals 5. Now, here, this is very simple to find what the middle term or the ratio is to find the series. We just take the problem and take this side and simply copy it down. This is, of course, if you're given this formula. Now, it states how to solve for the expressed for the series. Now what we do is we take the first term and we simply put it in to find the first term of the series. For example, n is here. This means that 3 times 5 to the 1 minus 1. Now what would that be? That would be 3 times 5 to the 0. And 3 times 5 to the 0 is 3 times 1. And 3 times 1 is 3. So that means the first term is 3. And you could keep going on like this until you solve it for 5. And that, ladies and gentlemen, would give you your series. Look at Billy there. It seems he's struggling with his math. Let's go check on him. Billy, what seems to be the problem?
Drew, I know how to do the easy problem, but I don't know how to do this hard one. I need the sigma again.
Then I'll give you the sigma. Here we are, ladies and gentlemen. You've already seen it, but this is the sigma. 100% guaranteed to get an A in your class. Here you go, Billy.
The sigma. Alright, let's get to work. So, we have to write this series in sigma notation. So first we have to test to see if it's a geometric series. And the way you would do that is that in a geometric series, the ratio of these two is the same. So basically that means that 3 over 1 is equal to 1/3 over 1/9. So 3 over 1 is 3. 1/3 over 1/9 is the same as 1/3 times 9 over 1, multiplying by the reciprocal. This simplifies to 3 over 1. So 3 is equal to 3. So this is a geometric series. So because of that, we can find the equation for it. So all we have to do is we have to find the first term. So t of n is equal to the first term, which is obviously 3, times the ratio, the ratio, and the way you would find that is basically just this term divided by this term, or this term divided by this term. You can do any of them, and it's going to give you 1/3 to the n minus 1. So that's your equation right there for the series. So now we're going to have to write it in sigma notation. So we got our sigma. We basically just copy this whole thing down here. So 3 times 1/3 to the n minus 1. Alright? So n is going to start out with 1, because 1 minus 1 is 0. 1/3 to the 0 is equal to 1. 3 times 1 is 3. That's going to be our first term. So now we have to figure out that what to the 1/3, or 3 times what to the 1/3 is going to give me 81. So basically, what's going to happen is that I'm going to plug in some number into here, and it's going to give me 1/81. So just like the last one with the easy one, basically we're just going to do it algebraically. So 3 times 1/3 to the n minus 1 is equal to 1/81. So 1/3 to the n minus 1 is equal to 1/3 to the 5. So now that you know that n minus 1 equals 5, n is equal to 6. So the top number here is going to be 6, and that is going to be your answer.
Alright kids, from the time that we have had together, I want you to learn one thing, that Sigma Incorporated is right for you. If you are not doing so well in your math class, then you need the Sigma. Now, if you believe that our program and our product is right for you, call 925-971-8967 or that number displayed on the screen. Now, if you call now, we will throw in a second Sigma for only $19.99. That's a $5 value. You're welcome. I know. Now, batteries are included, but not required. Okay, I just have to say this short thing. It's not very important. Disclaimer. Sigma Incorporated is not responsible for nausea, vomiting, criminal offenses, failing of class, serious injury, or even death. Thank you for choosing Sigma. Hello, kids. Today I'm going to teach you about the Sigma. Now, the Sigma is an old tradition that we use for math. And for math,